Hi everyone, welcome back to AI 900 Azure Fundamentals Prep Class Part 3. I'm going to try and be quicker on this one. So my name is Michelle Sanford. I am a Developer Engagement Lead at Microsoft. You can find me on the LinkedIn. Also, whenever I study for any of these exams, I always take notes and I put them on my GitHub profile. So if you want to go there and check those out, if you find it useful, give them a star. And part 3 is all about computer vision. Now, we have talked about all of these concepts before, and I went through them pretty thoroughly in part 1 in the introductory section because they are very interesting. But as I have said previously, I like to draw out a mind map and I'll put each of the concepts there, and then I'll try and think of examples as to what those things look like in real life. And I think that's a really useful way to study for this exam, because generally the format of the exam questions is around, if you've got this, what would you use it for? Or if something looked like this, then which of these services is it? Or what did you use to build it? So if you can identify what each of these things looks like in real life, what the scenarios are that you would use them in, then you're going to be pretty well set up for this exam. You remember this, well, perhaps you don't, but in the original version we had, in fact, I'll show you it. If you look here, this one that says semantic segmentation, that one is mapped out using that kind of pixel map. So computers don't have eyes, but they can process images using cameras, videos, and pictures to interpret the world. And to an AI application, an image is just an array of pixel values. And these values can be used as features to train machine learning models that can make predictions about the image and its contents. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, and images. And I've said it before and I'll say it again. Pretty much everything I say about the applications of the concepts or the concepts themselves is stuff that is explicitly there in the learning path. So if you read the learning path a few times, you will definitely have a really clear idea as to what all of these things are and how you can use them. So, as I say, we went through this in part 1, and I really like this picture because it does clarify in your mind that the difference between each of the computer vision services or workloads and what you use them for and what it looks like when you use them. So this is, if you can imagine those cameras that they have on the street, and it's scanning people as they walk around the city. I always think of that as New York. I think maybe it probably is with those yellow taxis, and they do have those cameras everywhere. It's supposedly, I mean, it's less problematic if you are just doing this bounding box technology, saying that's a person, he's wearing jeans, he's wearing a jacket, he's male, about 34 years of age, that kind of thing. When you start going down to the detail of that is John Smith, 34, lives in New Jersey, then it starts to get a little bit more problematic, because you have to be very careful when you are training AI technology to use people's private information. And it is private information when they are innocent citizens going about their business, not involved in anything suspicious in any way. I've done a lot of this kind of thing, which is image classification and object detection. What I most often did was training an Azure Percept device to recognize Lego people and to recognize Lego cones. And then I use that technology to with my obstacle avoidance robot, and it would move along, and if it saw a Lego cone, it would turn, and it would keep turning until the cone was no longer in its way, and then it would go straight. And we were training it as well to avoid the Lego men, and that is in our minds how we were clarifying how autonomous vehicles would work. Of course, they're a lot more sophisticated than the model that we made and how we did it. The other delightful thing that we noticed when we were training that was that there was already a lot of knowledge inbuilt, and so they call those domains. So the general domain, for example, recognized books, it recognized people, it recognized desks, it recognized floor, and we didn't need to train it for all of those things. It could automatically pick those things up. Also, when you're doing object detection, the AI is never 100% sure. This is unlike people. You'll notice that a lot of the time people claim to be 100% certain that they saw something or they saw someone, or whereas the AI is a little bit more truthful. It will say that it's 97% sure that that's a banana, it's 96% sure that's an orange, and that's I think quite useful in that sometimes an orange is a ball that is orange in color, and from a distance it might look like one thing and in fact it's another thing. It's good if you can allow a little doubt to creep in, and yes, there's something we could learn from the machines, is what I'm saying. Face service. Now here we are identifying people. This is interesting because it is slightly more problematic when we get down to the level of who they are and how old they are, because these are two pieces of information that can be used to identify someone and can be used to steal someone's identity, I guess. So you have to be very careful when you are using facial recognition and when you are using computer vision services for that kind of facial analysis. Remember the responsible AI principles we talked about in chapter 1 as well. Reading text with computer vision, this is the one that I use all the time, nearly every day. And I would imagine that as students, that is also something that you use a lot as well. In my day, I remember photocopying books from the library because I couldn't afford to buy those books myself. Photocopying books was a bad thing back then for copyright reasons. But today, you can get a lot of those books in online format or in PDF format, or your lecturer might produce stuff for you in that format. You can convert those things to notes by just, importing them and then putting them directly in. I will often take a picture of something like this shopping list and then I paste it into OneNote. I'll right click on it and say take text from image, and it will put the text in my OneNote, and it's really good. In this case, you wouldn't really need it necessarily, but a lot of cases the writing might not be that clear, and so you might want to extract it out. Also good for tax. For doing your taxes, you can get all of your expenses, you can get all of your receipts, and you can extract that information from them and put that directly into some sort of financial tool or expenses form. Does not want to move forward. Oh, there we go. So these are all the concepts that we have talked about really briefly in this one, but I did go through them in a lot more detail in actually the overview module 1. Let's do some practice questions. So assessing damage to a car from a photograph is an example of image classification, object detection, OCR, or semantic segmentation. So let's rule some things out. OCR, that's receipts, that's invoices, that's forms, that is text in an image into something else. So it is definitely not that. Semantic segmentation is there where we're sort of colouring in very precisely, whether it's a car or a person, pixel by pixel, to making sure that we have absolutely identified what it is. So that's a kind of object detection one. B is object detection as well, and that's sort of, is it an apple? Is it an orange? Is it a taxi? Is it a car? Is it a human? Image classification, though, we can classify, is that an undamaged Toyota? Is that a Toyota with a damaged bumper? Is that a Toyota with a damaged front panel? Is that a Toyota with broken lights? It's kind of it can predict the category or class that the contents of an image belong to, and a set of images is used to train the model. So you can have, lots of beautiful undamaged Toyotas, but then you could have lots of pictures of Toyotas in various states of damage, and you can apply to them the cost of each level of repair, so that it would be able to predict using that how much damage there was in that car. Does not want to move on at all while it's thinking about that. There we go. So which of the following is a scenario where you would need to use an optical character recognition solution? Oh, so I really like this question because, in fact, you could use OCR as a solution for each of these answers if you were getting creative. And so what you really need to do here is look for the unequivocal answer to this solution. So OCR, it's forms, it's receipts, it's PDFs, it is text in images. And so therefore, C, the processing and validating invoices, is the correct answer for this one. However, depending how you read each of those other ones, you could make a case for an OCR solution. They just wouldn't be the best one. So for example, validating identity for access to business premises. If the way you validated identity was you had the person stand in front of the camera at the gate holding their driver's license next to their head, then maybe you could do some OCR there and double check, is that someone you're expecting based on their driver's license? Is that a valid driver's license? That kind of thing. That's not the obvious one because the trick is not to identify the writing on the driver's license. The trick would be to match the person's head to their image in the photograph. So, not OCR. The second one, identifying products in a warehouse location. Well, if you were having a camera read the labels of all the products and identify them as a result of that, then that would be OCR. But I think that generally what it's saying is it's doing object recognition, and it's recognizing the objects based on the containers they are in, the boxes they are in, that kind of stuff. So therefore that is object detection, not OCR. And then the final one, evaluating compliance with building safety regulations. Well, you could also be looking for signs that say fire exit or, do not walk here kind of things. But in fact, probably the more likely thing that it is asking about there is, does it, can it pick up all the fire hydrants? Can it pick up that there are fire exit doors? Can it pick up that there is enough space between aisles for people to safely pass? So it's more likely doing object detection there as well. Yeah, so there we go. So, you know, you need to slow your mind before you get to things like that where you're thinking, oh, it could be all of these. Don't panic. Pick one, come back to it at the end, and then you'll have time to sort of read through them slowly and say, do you know what? Obviously, it's C. Which two Azure Cognitive Services can be used to analyze faces within an image? So, face, computer vision, personalizer, form recognizer, text analytics. So again, let's rule some out. We want to pick two. You need to be careful of questions like this, because if you only pick one, because you've been picking one in all the other cases, then you'll miss the points that you would have got from picking two. So, you know, you still get points for one, but not as many as if you pick both of them. Actually, sometimes it will say that clearly. So it will say the two components make the correct answer. So in that case, you need to get two of them in order to get it correct. But more often on a fundamentals one, it will say each one is a complete answer in and of itself. And so you get points for each of them. So better to get 2 points than 1 point. Okay, start at the bottom. Text analytics. You don't analyze faces with text analytics, you analyze text. Form recognizer. You don't analyze faces with form recognizer, you recognize forms. Personalizer. Now, that might be a little trick if you're not familiar with it, in that you might think personalizer, but no, personalizer is where it is matching products to known preferences. So, you know, I like to buy science fiction books. Here are some more science fiction books. Or I like movies with Meg Ryan and Tom Hanks in them. And here are some more movies with Tom Hanks and Meg Ryan in. So then we've only got two left, and they are face and computer vision. And obviously we analyze faces with face, and computer vision, obviously we are looking at things and people. And so we can use that to detect human faces and predict their age and gender. Match the requirement to the face recognition operation. An operation may be used once, more than once, or not at all. So this one's a tough one, actually, because, well, in my mind, it's tough in that I have to really think and sort of logic out what each of the things are. So evaluate whether two faces belong to the same person. So what we have here is maybe we have twins, identical twins, and we want to know whether the laptop should open for George and Dennis, or should it just open for George, whose laptop it is. That technology is really good, and it can tell the difference between identical twins, even though blood DNA technology could not tell the difference. Facial recognition can tell the difference, and it uses verify for that. So it is verifying whether it is the same person. It is identifying each of the people. So it would identify George as George, or it would identify Dennis as Dennis, but it will verify whether Dennis is George or George is Dennis when one is looking into the laptop of the other. And if they were not the right one, it would reject them. It would not let them log in. Extract faces that look alike from a list of faces. But then there's also divide a set of faces based on similarities. So I am going to say extract faces that look alike from a list of faces. I'm going to say that is find similar. Find similar operation takes a face you have detected and extracts faces that look alike from a list of faces that you provide. Find similar returns a subset of faces in the list. So, and then the last one, divide a set of faces based on similarities. That would be the group then. So group operation creates several smaller groups from a list of faces based on the similarities in the faces. So it could group all the people with brown hair, all the people with big noses, all the people with mustaches, all the people with 2 ears. I don't know. Yeah. So you see, you need to learn what each of those is and be able to identify them, because this is a a definite common question. What is the process of applying class or category labels to images according to their visual characteristics? This is image classification. Classification. Like that's literally the definition. Object detection is detecting objects, and named entity recognition. This is a text thing, so it will classify predetermined types or categories such as people, products, and locations. Okay, this is just a reminder. It's a fundamentals exam. Don't stress. You don't have to have an in-depth knowledge of how Azure services work. It's a simple exam format. No long-winded questions or case studies. In fact, even if there are case studies in here, I would say you don't have to read them. You would be able to logic out the answer to the questions without even looking at the case study. I mean, that has always been the case when I have taken them. Stay calm, read the questions, answer every question, trust yourself, answer quickly, review later. And if you are a university or TAFE student in Australia or New Zealand and you've not already registered for MSA 22, do register and we'll be able to study more together as we go. Thanks for joining me today. I'll see you in the next video.